In this video we're going to be introducing a different way to solve quadratics. It's called completing the square, or to complete the square. A couple of things we need to talk about right off the bat. This is a technique that you use if we have what's called a prime quadratic. If you think about prime numbers are numbers that can't be factored. So similarly, quadratics that are prime cannot be factored. We can't use any of those factoring techniques that we talked about earlier to solve these. We have to use one of two methods. The first is called completing the square, and the second we'll get to in a later video, but you should already know it. It's called the quadratic formula. So these are the two methods that we're going to use to solve quadratics that we cannot factor. Completing the square is kind of a tricky thing to get at first, but the more you practice it, the quicker you get at it, and the better you get at it. So let's do some examples here. If we have a quadratic that looks like this. So we try and factor it. We say, what are factors of our last term here? What are factors of -3 that add up to 10? Well, there aren't. The only factors of 3 are 3 and 1. And there's no way we can possibly make that add up to 10. So this here is a prime quadratic. And we can only use two methods. And this is one way we can do it. Rewrite A and B and the terms that go along with those. So basically rewrite your first two terms as is. We're not going to do anything with those just yet. But in between our bx and our c here, we're going to do something. And this is the first step of completing the square. We're going to take b divided by 2 and we're going to square it, and we're going to put that right in the middle of our b and c terms. We're also going to do the same thing to the other side. So we need to take whatever this equals and balance it out so that we do it to both sides of the equation. That's a general algebra trick, right? So what do we get when we do b? Well, b is 10. 10 divided by 2 is 5, and 5 squared is 25. Let's rewrite everything. We haven't done yet. And we got the same thing over here. 10 divided by 2 squared, so we write 25 over on the other side. Take this. This right here is what you need to do to complete the square. So don't ever take this answer, this, for example, this 25, don't subtract 3 from it. Keep this thing all by itself. This is our trick. This is completing the square. We just made a prime quadratic into a perfect square, which now we're allowed to factor. This is our perfect square factoring. If you remember that factoring pattern, we're going to have one set of parentheses with a squared on the outside, because we're going to square whatever is on the inside. That's a perfect square. We write the square root of the first term, so x goes there. We write the square root of the last term, so that's 5, and we put the middle term's sign in between them. We still have -3, and we still have it equaling 25. Well, if we add 3 to both sides, then what happens here is we now have a binomial that we can square root. And we can get rid of the square, and we can solve for x to the first power. So we did two things here. One, we turned this prime into something we could factor. And second, we turned this power of 2, this square right here, into a power of 1. And those two things are really what's required to solve for x. So if we square root both sides, if you're solving any square root both sides, you always want to write plus or minus, right? And we're taking the square root of 28. Let's simplify the square root of 28. That is 4 times 7, right? So we take the square root of 4 out of the radical. So we're going to put that on the front of it. 7 still under the radical. We still have plus or minus. We still have x plus 5 on the left side. Well, we just have one more step to solve for x. If we subtract 5 from both sides, we get x equals negative 5 plus or minus 2 times the square root of 7. There's our solutions. That's what x equals. Alright, let's do another example here, because this is tricky. Well, let's do 3x squared minus 6x plus 12. Now, if you noticed on that last example, a was 1. This is an example if a does not equal 1, well, we got to do one extra step here. We always got to set a equal to 1, or get a equal to 1, and the only way to do that is to divide every term by a. That will get rid of that coefficient and get it down to 1. A has to be 1 in order to complete the square. So let's just reduce. We got x squared minus 2x plus 4. Now let's look at this quadratic. Is it prime, or can we factor it? Factors of positive 4 that add up to negative 2. Well, that's not possible. We can't have factors of 4 that add up to negative 2. So this is a prime quadratic, and we got to either complete the square or use the quadratic formula. So let's complete the square, because that's what we're doing right now. So we rewrite ax squared and bx as is, but in between bx and c we got to add b divided by 2 and square that. Okay, we got to do the same thing to the other side of the equation as well. That's often something that people forget to do. If you do something to one side of an equation, you got to do it to the other side of the equation. We got to keep our equations balanced. Both sides have to stay balanced. Let's simplify a little bit. Negative 2 divided by 2 is negative 1, and negative 1 squared is positive 1. Remember, this is our square. Let's simplify this other side. We get exactly what we got right here, so we might as well just rewrite it. And now we use our perfect square factoring pattern to factor this down to a binomial squared. So square root of the first term, square root of the last term, well, the square root of 1 is still 1. And we use our middle term sign. So this trinomial factored is actually x minus 1 squared. Now if we subtract 4, then we get x minus 1 squared equals negative 3. Let's square root both sides. Bring it on over here. That leaves x minus 1 equal to plus or minus, square rooting both sides, the square root of a negative number. So we take out I, and we leave the square root of 3. Alright, just add 1. That's our last step. There's 1 plus or minus I times the square root of 3. That's our final answer. Alright, so one more thing I want to talk about here. Completing the square also does something else. So let's do one more example here. Let's do x squared minus 8x plus 11. Another thing completing the square actually does is it allows us to put a quadratic into vertex form. So if you remember a little while ago when we were talking about the vertex form of a quadratic and graphing it, let's see what happens. How can we do this? We use our completing the square steps. So rewrite ax squared and b. We're going to do b divided by 2. This is what we're adding, sorry. Squared. Do it to both sides. So x squared minus 8x. Negative 8 divided by 2 is negative 4. And negative 4 squared is positive 16. So there's our trinomial that we're going to rewrite. Rewrite the same thing over here. So this becomes our perfect square factoring pattern. Square root of the first term, square root of the last term, middle term sign. Now right here, this is where normally if we were solving for x, we would subtract 11 and keep going by taking the square root of both sides. But what we can also do is take care of this number on the other side. So you can kind of think of y being over here on this side, and if we subtract 16 from both sides, then we get x minus 4 squared minus 5, and that equals y. Well, right here, this is our vertex form. And if I write it maybe in a different order, just flipping sides here, then maybe it looks even more familiar. Here's our vertex form. Our vertex is looking right at us. Our vertex is the opposite of this, the opposite of h, so positive 4, and whatever this k value is, negative 5. That is the vertex of our parabola, or the vertex of our graph. So completing the square allows us to get a jump start on our graph by showing us the vertex. And it also tells us our x-intercepts if we were to solve for x. So let's solve for x. Let's go back a step here. See if I can do that quickly here. So if I just back up a step. Okay, this is kind of our crossroads right here. After you've completed the square, you can do what we just did to find the vertex and graph it, or find the x-intercepts. Oops, changed my stroke here. Subtract 11, do what we were doing before, and solve for x. So here we get 5, take the square root of both sides, we get plus or minus the square root of 5, and just add 4 to both sides. And there's our x-intercepts, or the solution to the quadratic. So two things. We solved for the vertex and the x-intercepts. So completing the square allows you to do that. You can do that even with quadratics that aren't prime. You could complete the square and find the vertex, find the x-intercepts the exact same way. It's just really helpful when we're dealing with prime quadratics. Alright, so in the next video we'll talk about our second way of solving prime quadratics. That's called the quadratic formula. Alright, so good luck completing the square.